Welcome, everyone, and thank you for joining us for this program with the San Antonio Book Festival. I'm Caren Creech, and I work for the Patrick Heath Public Library in Boerne. I'm so excited and honored to be able to introduce Dr. Kate Biberdorf. She's a scientist, a science entertainer, and a professor at the University of Texas at Austin. Through her theatrical, hands-on approach to teaching, Dr. Biberdorf is breaking down the image of the stereotypical scientist while reaching students who might otherwise be intimidated by science. Students' emotional responses rather than rote memorization of facts are key to her dynamic approach to the program, as well as science in general. Her exciting and engaging program leaves the audience with a positive, memorable impression of science, all while diminishing the stigma around women in science. She has appeared on The Today Show, The Wendy Williams Show, and Late Night with Stephen Colbert, and many others. Her latest book is titled Kate the Chemist, The STEM Night Disaster, and she has 2 new children's books coming out on May 11th, The Awesome Book of Edible Experiments for Kids, and Kate the Chemist, The Birthday Blast-Off. So I just wanted to mention also, before I turn it over to you, Kate, make sure to support the San Antonio Book Festival by purchasing your books. And this is the latest of Kate's books, but make sure to purchase them through the Book Festival and the official book store of the Book Festival, the Nowhere Bookshop. So thank you very much, Dr. Kate, and we'll turn it over to you.
Thank you so much for that lovely introduction. I wish I could take you everywhere with me. Thank you so much. And hello to everybody at home. Thank you to parents. Thank you to children. Thank you to everybody, librarians, everybody at home, grandma, grandpa, mom, dad, whoever is there. Thank you so much for showing up today. I am so excited to be here and so honored to be part of this book festival. I'm in Austin, so if you are in San Antonio, I'm just so close to you. We're just a little bit away from you. But I'm so honored to be here, and thank you so much for taking time out of your busy schedule, your busy weekend to hang out with me. So what I'm going to do today with our short period of time is go over a little bit about who I am, my backstory, why I'm allowed to blow stuff up, and then I'm going to tell you more about my books. And then because I can't help myself, I do have 1 or 2 explosions we're going to do, just because I can't help it, right? If we're going to talk about science, we might as well do some science, right? All right, so I'm going to go ahead and share my screen because I think it's just a little bit better to share some pictures too, so you have an idea of what I'm referencing. So hopefully you all can see my screen right now. Okay, so I'm going to go ahead and get started. So this is just my little presentation with some pictures, but hi, like I said, my name is Dr. Kate Biberdorf. I go by Kate the Chemist when I travel. This is what I looked like as a baby. I think you can see by my eyes that I've always been a little bit excited and happy, and my parents should have known I was going to be a pyromaniac. I'm originally from Kalamazoo, Michigan, so my O's come out when I get really excited. You might hear them later on. But the main reason I'm showing you this is because I had this one amazing teacher, that woman right there. Her name is Mrs. Kelly Palsrock, and she was just so amazing. She would run around the classroom. She was energetic and excited. She would light stuff on fire. She was just so incredible. And honestly, her passion for chemistry was so amazing and so contagious that ever since I was 15, I knew that I wanted to be a chemist, and I've never looked back. So after I graduated high school, I went to the University of Michigan. Go Blue, if there's any Wolverine fans out there. I majored in chemistry and German, and the only reason why I majored in German is because they gave us extra money to study abroad, and I was like, okay, I'll go to Germany. That sounds like fun. After I graduated, I packed everything up in my car, my little Camry, and I drove all the way across the country from Michigan to Texas. And so here I was at the University of Texas to get my PhD in inorganic chemistry. So I spent 5 years studying different catalysts that were active for the Suzuki-Mirror cross-coupling reaction. Now, I do not expect you to know what the Suzuki-Mirror cross-coupling reaction is at all, but basically what I did is I took one molecule and I added it to a solution where there were other molecules there, and the one molecule that I added caused a chemical reaction to occur, and that ended up speeding up a reaction. So it made the reaction go really, really fast once I added this special molecule. So I studied that for about 5 years, made a lot of progress on it, and after I graduated, I started teaching. So over here on the left picture, you might be able to see me. I'll give you a second to see if you can find me, because what I do now is I teach general chemistry for 500 students in the classroom. So here's my picture. There I am right there. I'll help you. So I'm standing right there in the middle. So I have 2 classes of 500 students. So I have about 1,000 students per semester. Take a second and think about that, right? Think about having 499 other students in your classroom, right? It's insane. It's absolutely crazy, but it's so doable if we have these little workarounds. And so as you can see here, I'm not standing at the front of the classroom just lecturing and being boring, talking about chemistry. Instead, we run around the classroom, and you can see in the picture, there's a bunch of other people standing up. So there's a bunch of people that work for me, and we all run around the classroom when we talk about chemistry so that everybody can hopefully understand the concepts. However, as you all know, we have not been gathering like this over the last year. So my last year has been looking more like this. That's how I teach. That's how I do these presentations. So you can see I have 3 monitors set up. I have 2 huge lights. I've got a microphone coming at me. But I just want to give you a visual about what my side of the camera looks like. So this is how I teach. I'm a professor of chemistry of instruction at the University of Texas, Hook'em Horns, and I've been doing that since 2014. So now, you might have noticed that I have a little bit of energy. And so for me, teaching, and I don't want to say just teaching, but just teaching for me was not enough. Like, I had so much energy, I needed another project. And so what I did is I went to my boss and I said, please, 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 you have to give me another project. Like, I have all this extra energy. You need to let me do something with it. And so what we did is we started this program called Fun with Chemistry. And so Fun with Chemistry is my local outreach program, and we started off really, really small in 2014. So we went out to just local Austin schools, and I started blowing stuff up and trying to get kids really excited about science. Here you can see in this picture, I have this like, oh no, oh my goodness face, because Henry is so excited about science. I was worried he was gonna knock my graduated cylinder over. Nothing bad happened, thank goodness, and he was having a great time. But you can kind of see how we were able to use these experiments and spread the joy of chemistry throughout Austin. Well, one thing led to another, and I started getting invitations to do things across the country. So I was doing some shows in New York and LA. I started doing stuff in Newton, Iowa, Roswell, New Mexico. But then I started doing stuff on TV. And so all of this started just because I said yes to one question. So let me tell you the story. So I was sitting at work doing this stuff, right, like getting ready to do a chemistry show. I think I was answering emails, actually. So right, I was answering emails. This is what I look like answering emails. And an email came in from my colleague, and it was like, hey, Kate, we're going to be on We Are Austin, which is our local variety show. And he's like, we're going to blow some stuff up. We want to make it exciting because we're doing this boring lecture, and I want to do something really, really exciting on TV to get people to come to the lecture. He actually said boring lecture. Can you believe that? I couldn't believe that. Anyway, so I was like, well, why don't we blow stuff up on TV and try to get people to come? So I went there. I didn't even have a mic or anything. I was just like handing him some stuff, some science experiments, some equipment. He did the explosion. It went really, really well. And then all of a sudden, this lady, after the segment was over, this lady comes running into the studio, and she's like, that was amazing. Do you guys do anything for Halloween? And I was like, yes, we do. Yes, we do. And so I pushed this guy out of the way, and I ran at her, and I was like, yes, I can make a pumpkin vomit. I can make it explode. I can make it do this, 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 and this. And she was like, okay, sure, just come on back. So I did an experiment for Halloween, and then she was like, what about Thanksgiving? So I did something for Thanksgiving, and then New Year's, and then something like April Fool's or St. Patrick's Day. And so I just kept coming back month after month and doing a science experiment on TV. And so I started working on my science communication skills and talking about science in a fun way to try to get people interested in it. Well, apparently Pickler and Ben, which was a national show, saw my We Are Austin segments. They were like, hey, come on to our show, our national TV show, and do an experiment. I was like, okay, that sounds like fun. So we did this experiment called Elephant's Toothpaste, and in the experiment, in the rehearsal, the elephant's toothpaste only went like 5 or 10 feet in the air. Like, it didn't go very high. They're like, can you make it bigger? And I was like, I can make it bigger. And they're like, make it bigger, make it bigger. I was like, okay. And so I dumped so much catalyst in there, and you can see in the picture that the stuff went all the way up. It hit their roof, their ceiling, it went all over their ceiling. They had to bring this thing out to, like, that was like this really crazy ladder to go all the way up there and try to wipe it off the ceiling. But it was was amazing, and I had so much fun. Well, Wendy Williams saw that, and she was like, could you come do that in my show? And I was like, sure, no problem. Then Stephen Colbert saw that, and he was like, could you do that on my show? And I was like, sure, no problem, let's do that. And so I'm really, really proud of this segment in particular because, one, I got Stephen Colbert to breathe fire, which is like amazing. How cool is that? But number two, I believe I was the first female scientist to ever perform a science experiment on late night television. And so that's something I'm really, really proud of. I love the fact that I was able to use science and kind of make it look good, bring it to late night television, and show that you can be feminine and you can wear earrings and you can wear makeup and have cool shoes on and fancy shoes. If that's your thing, you can do that. You can be feminine and be a scientist. You can be anybody you want to be and be a scientist. Literally anybody can be a scientist. So I was really honored to be part of that. However, when all this happened, like all these TV segments happened within about a 6 month period. And so I realized, like, without intentionally trying to do anything, intentionally trying to be the first woman on science, doing science and lightning or anything like that, it just kind of fell into my lap. And so I realized that I had this platform. I've been given this platform without trying to like have it. But I knew that if I didn't do something with it, if I didn't use this opportunity and make something with it to, make the world a better place with it, I would regret it for the rest of my life. And so I started thinking about what I could do, and I took a note from Taylor Swift. So she has her squad, and I was like, well, that's kind of cool. So I decided I was going to try to build what I refer to as my STEM army. And so what I do is I go around the United States and I collect people in a non-weird, that kind of sounds weird, but I collect people and I try to get them to be part of my army. So here we can see tons and tons of different girls. These are all undergraduate and graduate students that are all working together. And like what we were doing in this particular thing is we were trying to set a record for the most explosions, the most thunderclouds you could possibly do at one time. So we did 70, and it was one of the best days of my entire life, and it was so, so incredible. However, what we were doing there was just beneficial to graduate students and undergraduate students. So people that were between like 18 years old and maybe like 25, 26 years old, around there. And so I realized that, yeah, that was cool. Like, yeah, I had a lot of people coming there and we were working together to try to, diminish the stigma around women in STEM. But I was missing this giant population of students. So the elementary students, the middle schoolers, the high schoolers. And so that's when all of these books started. That's where all this came from. And so I'm super, super grateful that I was able to partner with Penguin and Philomel in particular, because we came up with the Kate the Chemist series, which now is a 7-book series. I can't believe there's 7 books all together. They're all coming out here soon, so it's so exciting. But here was the first one that came out, and this is called the Big Book of Experiments, and I'm going to show you one of these experiments later because I can't help it. I absolutely have to show you an experiment. So this is the Big Book of Experiments, and in the Big Book of Experiments, what we have are 25 different experiments using materials that you probably have at home right now. So when I wrote this, I was thinking about all the different kids that I interact with on a daily basis. So when I go to Newton, Iowa, or California, or Washington, or Florida, like no matter where these students are, I wanted to make sure that they could actually do these experiments. So I use things that you probably have in that pantry or that drawer in your kitchen that has everything. So for me, that's where my tape and my scissors and my string and my crayons, all that's in that one drawer. So I tried to make sure that whatever was there, what's in your pantry, are what I started with to build these experiments. Yes, I definitely got a little creative once or twice and stepped out of that. So you might need to order 1 or 2 things from a store, like a hobby, a craft store, there we go, or something like that. But most of these things you probably already have. And so it's been doing pretty well. We were called one of Amazon's best books of 2020, so I'm really proud of that. And one of the reasons why I think we got that stamp of approval or whatever you want to call that is because I think we made it fun. I took these experiments and put a twist on it. So instead of just saying like, here are some bubbles, I showed y'all how to make a bubble snake, and I'm actually going to show you this one later. But you can also see that in the book, I have a lot of different features of it. So there's a messiness level, and so that tells us how messy the experiment is going to be. I go through and actually show you step by step with pictures how to do each step, but you'll also see there's lots of pictures, and I try to show that it's okay to be feminine and be a scientist. You'll see that I have my pink goggles on there. I have my earrings on. I have my jewelry on, and because that's who I am. I am being true to my authentic self, and it is okay to be a girly girl and be a scientist. I also did an experiment called unicorn glue that I just love. And so this was the last experiment after days of photo shoots, days and days of photo shoots to get all these pictures. It was our very last picture, very last one, and we finally got the glue to work because it was just taking a second because we had an issue with the hot plate. So when we finally got that figured out, we were able to get the glue to work, and we made the corn, and I just smacked it on my head. So then, of course, the photographer got a picture of that, and the editor loved it. So we have a picture of me with a unicorn horn on my head. Yes, I'm a chemistry professor, but it's okay to be goofy as well. So that's one of the things in the book, and I just really think that you will like that if you want to go out and explore some more chemistry. But what I'm here to talk to you about today is my fiction series. And so my fiction series is the series that accompanies the Big Book of Experiments. And so the Big Book of Experiments is something that I wanted to do growing up. Those are the experiments that I would have wanted to do, to break things apart, put them together, and figure out everything like y is x plus y, give me b or whatever. That's what I wanted to do. But my sister, not so much. She wasn't into that. And so when we partnered with Philomel, what was really important to me is that I made sure that I had this fiction series as well. So this fiction series that accompanied the nonfiction. And so what it is a 5-book series. So the first 3 books are already out, and the next one comes out on May 11th. But what it is a little 10-year-old Kate the Chemist. And so what she does is she goes around her neighborhood and she tries to use science to solve her everyday problems. So the very, very first book is this purple book. You can see it on the left there. That's called Dragons versus Unicorns. And so Dragons versus Unicorns is a fun book, y'all. Oh my gosh, I had so much fun writing this one because it was the first of the series. I went nuts. Like, I start the book with little Kate breathing fire because why not, right? I tried to have fun with it. Obviously, my mom never let me play with fire when I was 10 years old, so I had to have a little fun with it in this series. Especially because as a scientist, we have to be accurate. Everything we have to say, everything we say has to be on point. Our science needs to be 100% accurate. You can't misspeak. You can't have any of those issues. So it's so fun with the fiction series is I got to be creative. I got to make up stories. I get to say, what if this happens? Let's say this happens. And it was just so much fun. So what I love about these books, though, is at the very end of the story, I always include an experiment that the characters actually did. And it's always an experiment that's really important to the story. I don't want to give too much away. I try not to say too much during these talks because I want you to actually read the story because I think you'd enjoy it. But in the first one, you all make unicorn glue, which is the one I was just telling you about from the Big Book of Experiments. And so the unicorn glue ends up being really important in the story. And again, I'm not going to say much, but so hopefully, maybe if you weren't into science, or maybe you're intimidated by science, or for whatever reason, you know, it's not your thing yet. Hopefully, once you've read the story, you can see how cool chemistry is and how it's everywhere, and we actually get to interact with science on a daily basis. And so by the end of the story, hopefully you're now more inclined, more interested in actually doing that experiment, doing on the hands-on learning. And so I always include an experiment at the end of my fiction books. The second book, the fiction series, is called The Great Escape. Y'all, I can't even tell you how much fun this one was, because what I did is I came up with the idea of a chemistry escape room. I was like, I would love to have an escape room where the kids get to use chemistry to get out of there. They have to use science clues, solve science clues to get out of the escape room. So in the escape room, oh God, I don't even want to say anything. Okay, I'll stop. All I'm going to say is that that they need a periodic table, and so we talk a little bit about the periodic table in the story, so they know how it works. And then at the very end, when they go through this to try to get out of the escape room, there's an experiment that's really, really important, and I'll just shut up right there. I don't want to say anything else. However, in this book, I do teach you how to make magnetic slime, which is so much fun. One thing I will caution you with, if you ever do magnetic slime, don't put the iron oxide powder down your drain. It will ruin your dish disposal. You don't want to do that, your drain disposal, excuse me. So be really careful about that. Always dispose of your stuff properly so that stuff goes in the trash. Okay, so now the Sam Night Disaster. Woo! This is the one that just came out, and it is being so well reviewed, which I love to hear. I love when my stories are well received. So the Sam Night Disaster was so fun to write. Oh my gosh, it was so much fun, because what we did for this one is I decided that I wanted to have the girls have their very first night, STEM night, like ever. Okay, so that for the elementary school is their very first STEM night. And so what happens is the girls needed to come up with a science fair project, and they were going to kind of present it. It was going to be this project, right? So they're going to compete at the end. So it was a big deal. And so what happens is these girls start working together, and they start working on their science projects. And I'm actually going to stop sharing my screen really quickly. Oh, where'd that slide go? Hold on one second, guys. There we go. Stop sharing my screen. Because now what I want to do is just kind of talk about these books just a little bit more here. So here is the one that I was just telling you about, called The STEM Night Disaster. Like I said, these girls are working on their experiments, they're working on their science fair projects, and so right now in the story, where I'm going to kind of do just a little reading for you so you can kind of see how it works. Right now in the story, what's going on is little Kate has essentially figured out what she's going to do with her experiment. She knows finally what she's going to do, but she had a little hiccup. So last week, or I think it was the night before actually, what happened is somebody came in and they kind of sabotaged her. And so again, I don't want to give too much away, but that's where we're jumping in here. And so now what you'll see is that every single chapter has a little definition at the very top. And so it's my way of trying to sneak in just a little bit of extra science. And what you'll see is that in the chapter, that word is always worked into the text. So if you're on the younger age, what I want you to do right now is just listen to the story. It's a fun, amazing story. I'm biased, but it's a fun story right here. And so what I want you to do is just listen to it and enjoy the text. If you're on the older age, what I want you to do is listen to it from more of a science communication side. So I am a scientist who's obviously trying to get younger students to fall in love with chemistry. And so what I have to do is work the science into the text. And so I want you to listen to how I do that, like kind of find those science buzzwords and see how I kind of molded it and worked it in, okay? Obviously with a lot of drafts, and this is why we have amazing editors, obviously, but this is something that I'm really proud of, so I just want to share you with this here for you, okay? Okay, so here's chapter 10. Now I'm going to try to slow down because I'm notorious for reading my books too quickly, so here we go. Chapter 10, something's really up. The science definition here is electrochemistry. It's a noun, and it's a branch of chemistry dealing with metals. An electrochemist figured out how to make the coating on your sunglasses and the microchip in your computer. The next morning, Tuesday, I was skipping down the hall to class because last night I had figured out my Rube Goldberg machine. It was going to be so much fun to make. There was going to be stuff like a ramp, a pebble, dominoes, and Birdie Strawberry, of course. Birdie is Kate's best friend, and Birdie's actually based on my own best friend. That's her nickname, and so it was really important to me to name my best friend in the book after my real best friend, because she and I have been best friends ever since I was 15. So in that chemistry class, that's one of the reasons why we became so close. Okay, so behind me, Elijah hurried to catch up. Now, Elijah is Kate's other best friend. So Birdie, Kate, and Elijah are like this amazing little trio, okay? Wow, Kate, he called out, you're in a rush. Yep, I whirled around to wait for him. Then I explained to Elijah how I was going to put lemon batteries and the calculator into a Rube Goldberg machine. Now, a Rube Goldberg machine is what Kate's science project is, and essentially it's a lot like the game Mousetrap, if you've ever seen that. So what you do is you use kinetic energy to basically do a lot of things, like you have a marble knocks into some dominoes, which knock into something else, which flings something across the room, which turns the light on. And so it's this really complicated machine to do a very simple task, okay? All right, so so Kate figured out what she was going to do, and it's the Rube Goldberg machine. I thought about it all last night. I'm going to use a few lemons to power a little fan, which is chemistry and engineering, then blow a pebble down a ramp, which would be earth science and geology. The pebble will knock into the dominoes, which is physics, and the dominoes will push the strawberry, which is botany, you know, the study of plants, off the ledge into a cup of water. The water will overflow, wetting a piece of tissue paper that's underneath it. Through capillary action and more chemistry, the spilled water will creep up the tissue paper that has been pulled tightly over a small vertical plastic arm. The water will force the tissue paper to break, and the little plastic arm will pop up and push the button on a vertically standing calculator, which will also be powered by lemons. So cool, Elijah gushed. It's kind of like a game Mousetrap we have at home. That's just what Birdie said. I had called her about the machine last night. I just love that I'm getting so many branches of science into my demo, and I can explain all of them to Dr. Caroline. It's like I'm doing 6 projects in one. Okay, so now I'm going to skip ahead because I do want to save some time to do some experiments here, but I want to show you how I use electrochemistry in the text. So here we go. Luckily for me, I loved science, all of it. And I love that even with my Rube Goldberg machine, I was still doing some chemistry. Learning about how electrons move through metals was a branch of chemistry called electrochemistry. After gently stuffing all of my supplies, including the strawberry, into the back of my cubby, I turned to Elijah. I'm going to meet up with Birdie by the basketball court. Want to come? Sure, said Elijah. See you soon, said Mrs. Everlin. So I'll stop there. And the reason why I want to stop there is because Mrs. Eberlin, that is Kate, Bertie, and Elijah's 5th grade teacher. Eberlin is the last name of one of my colleagues who's also a woman in STEM. And so what I do is in the books, I try to name characters after other amazing women in STEM that are modern scientists. So if you want to find a little bit more information, you can use those last names and start Googling and read more about other women in STEM. So it's just another way to kind of like sneak the science in. So hopefully you could see that I wasn't just in the text yelling, science, chemistry, although I kind of was. But I tried to sneak it in as much as I possibly can so you can see the story. Like Kate is working on her science project, and so I just sneak in the fact that that's electrochemistry, or sneak in the fact that that's botany. All right, so at the end of every one of these books, like I said, there's an experiment. This one has 25 experiments. I've been talking about experiments nonstop. I think it's time for me to show you one. So here we go. Let me go ahead and just move. Let me move all of this to the side so you have some space. And so what we're going to do here is the very first one, because I want to show you how you could actually make yourself a bubble snake, okay? So the first thing you're going to need for this one is a plastic bottle. Now, technically, any plastic bottle will do here, but you're looking for something that has a mouthpiece here, and then you need 2 or 3 inches of plastic right there. So you can have a long bottle, you can have a shorter one. The important thing is that you chop off the end, so you have the mouthpiece and then the couple of inches of plastic, all right? You are also going to need a rubber band and then a rag. Okay, so this could be a t-shirt, it could be a towel. Mine is just an old rag. The big thing is don't use any paper towels. You can see why if you Google my appearance on Kelly Clarkson's show. She used paper towels and the whole thing disintegrates. It doesn't work at all, but it was a good science experiment and she looked awesome trying it. All right, so let's go ahead and get this part set up and then I'll bring more pieces over here. So what we're gonna do is take your plastic bottle, flip it upside down. So you're gonna hold the bottom down here. You're going to take the towel, we're going to flip it over the plastic bottle, and then I want you to pull the towel down. What we'll do next is grab the rubber band, and we're going to wrap the rubber band around the towel, just like that, okay? Beautiful, so we'll put that to the side. Now what we're going to do is grab our other pieces here. So I have some food coloring. Any food coloring can do, and you can also skip that step if you don't want to use food coloring. So you'll need a bowl and a spoon. And then you also need water and dish soap. So you'll need a 2-to-1 ratio of water to dish soap. So now today I'm actually using a 1/2 cup of water and a 1/4 cup of dish soap. So what we're going to do is dump both of these things into your bowl. Now it doesn't matter what kind of dish soap you use. The only thing that matters is that you have a lot of surfactant. So usually your natural dish soaps don't have a lot of surfactant. So I highly encourage you to kind of avoid those. So if it's clear and colorless, they aren't really the best ones for this experiment. So what's a surfactant, right? So first thing, stir, stir, stir if you're following along at home. So we're going to stir here. So what a surfactant is this really neat molecule, and it basically has 2 different sides. So there's one side that's hydrophobic and one side that's hydrophilic. What does that mean? One side likes water and one side doesn't like water. So in your shampoo, you have lots of surfactant. So you're going to go like this, and you get all the sides, and then the water comes through, and so here's how the shampoo works. So the shampoo has one side that doesn't like water. That actually likes your oil and your grease, the parts that makes your hair dirty. So that binds to your oil and your grease in your hair. Okay, like that. Then the water comes through, and the other side of the surfactant is like, whoa, I like water too. So that part grabs the water. So you have one part of the molecule that's hanging onto the water, one part of the molecule that's hanging onto like the oil and the grease in your hair. And so as the water goes down through your shower, what happens is the shampoo pulls the grease out of your hair and then goes down the drain with the water. We're going to activate those same type of principles here. So what we want for our surfactant is something that really, really likes water. That's the part that we're activating here in the water. And then we also have a side that really doesn't like water. And that part is going to help us trap some bubbles. All right, so now I've stirred that enough. I think we're good. So now what we're going to do is the last piece, we're going to prep our apparatus. So now I have tons of different food colorings here. I've got yellow, green, blue, and red. Do y'all have any votes at home what I should use? We'll give you guys a second to respond if you guys have any votes. Yellow, red, green, or blue. Okay, otherwise I'm going to pick, which I don't mind. Okay, I'm going to pick. We got red. And then let's see here. What else would be pretty with that? Maybe a green. I think a green. So here's your red. And so we'll add the green. I highly encourage y'all to use stripes. Okay, you can use spirals or patterns if you want. Kelly also did that on her show. Again, it kind of like blurred together and looked a little goofy. So do what you want, but I highly encourage you to use stripes. So what we're going to do is you're going to take this apparatus, flip it upside down. You're going to pop it right into the soapy water solution, pull it up, and let it drain. I'm someone who hates that food coloring. I don't like those messes, so you can see that draining there. We're going to let it drain for a second because I don't like it. Now you're going to take a deep breath in and make a bubble snake. Isn't that awesome, y'all? So what we've just done there is we've allowed for our surfactant to actually trap all of those bubbles. So all of those bubbles, everything you exhale that's in your all those molecules that you exhale get trapped within the bubbles. So those molecules are like nitrogen and carbon dioxide. You also exhale water and oxygen, some argons in there as well. And so all of that gets pushed into the bubbles and they're trapped in there, which is super, super cool. Isn't that fun? I really like that one. Okay, so I have another one for you. And so this one is because I like to take things up a notch here. Let me just see if I can move this bubble snake. Can I move the bubble snake out of here? That might work. There we go. All right, so now I really like the bubbles, so I'm going to stick with the bubble theme here. And we're going to take it up a notch, though, because I think it will be more exciting. So for this one, what I have is a water jug. So you can do part of this at home, but like I said, I'm going to take it up a notch. So you've got a water jug here, and I'm going to add a couple things to it. Now I'm going to add some actual molecules, some chemicals here. So I'm going to go ahead and put my safety equipment on, just in case my lawyer's watching. So don't do this at home unless you have your safety equipment on. And so your safety equipment should always include 3 things. So you're going to have gloves on. Your gloves are going to protect your hands. You're going to have your goggles on to protect your eyes. And then you need to have a lab coat on to protect your body. Honestly, you don't have a lab coat, no big deal. So just make sure you're wearing like a long sleeve shirt or something. You always just want to protect yourself. All right, so in my soda bottle, all I have is water. But what I'm going to do right now is spike it with something called universal indicator. So universal indicator is going to basically tell us if there's a chemical reaction going inside of this vessel. And the way we do that is because this universal indicator is actually kind of special. I almost said magical, but that's not true at all. It's always science. So what happens here is this indicator is a solution that has 5 different molecules in it. And each one of those molecules changes color based on the pH of our solution. So right now what we can see is we kind of have like a greenish, bluish color, kind of looks murky. So what I'm going to do is spike it with just a little bit of base. Okay. And we're going to make it purple. Okay, so we just brought it a little bit more basic. And so now what I'm going to do is bring a cryogenic out. And so let's go ahead and add some dry ice in here. And so dry ice is a solid carbon dioxide. Okay, so it's something that's really cold. And so what I'm doing is adding it directly into the soda bottle here. And what I want you to do is just watch that purple color, okay? So we can see the purple. And as the dry ice goes in, what happens is it reacts to the water and it forms something called carbonic acid. And the carbonic acid is going to make our solution more acidic. And so that purple color, there it goes, starts to turn like a bluish color. Now it's more of like a green. Keep watching it. A little bit lighter. Ah! And there's our yellow. If I let it keep going, it will sometimes reach like an orange. We're getting there. And then if I really leave it for like another 10 minutes or so, it might reach a red. But what's cool is if you have some base nearby, you can actually add that back to your soda bottle, bring it back to that purple color, and as the carbon dioxide goes into carbonic acid, it drops the pH again, and you see that really nice yellow color, which is cool. Okay, so now I started this whole thing by talking about bubbles, right? So you're probably like, we haven't seen any bubbles, ladies. So let's do that in just a second. So let me get this going again. And so what I want you to do now is focus on what's going on with the dry ice, specifically in the fact that there's a gas coming out of the top. So when dry ice, solid carbon dioxide, goes into water, it goes through this thing called sublimation. Okay, and sublimation is a process where a solid carbon dioxide or solid any molecule turns directly into a gas. Let me add one more. Nope, not that one. I want this to be good for you guys. There we go. Okay, so now we've got this really going. we're going to get our second card. So I'm going to take this apparatus, which is a funnel taped to a tube, and I'm going to redirect my gas. Okay? So I'm going to redirect my gas into a bowl that is filled with bubble bath solution. Now I use bubble gum, bubble bath solution, but you can use any scent. What happens is you form these things called dry ice bubbles. And when you pop them, the gas comes out. Isn't that amazing? So you can use sublimation, which is a physical change, to get your carbon dioxide to go from the solid state to the gas state. You can use your surfactant, which is in the bubble bath, to actually trap the gas that's coming out of there. And then in the inside here, we have that chemical change that's going on where our dry ice went in, turned into carbonic acid, and then slowly dropped our pH from the higher basic piece, that purple color, down to green, which is neutral. And now we're all the way down here to this yellow and orange. All right, so now, because I have just a second, I want to see if I can do, if I can hold a bubble. Okay, let me try it one more time. Oh, that's cool. Sometimes I can make a snowman. That you saw that, right? That was 2. That counts. You guys all saw that. Hold on. Yes. Isn't that cool? Okay, so this one right here is like an experiment that I have in the big book of experiments. That one is called dry ice bubbles, but as you can see, I put a little twist on this one today because I wanted it to be fun for you all. And so I obviously can't just end my presentation with that. That was cool. I mean, I'll admit it, that was cool, but it wasn't like right home to grandma cool, right? So we need to figure out what would be right home to grandma cool. So let's see if we can figure that one out. So for this one, what I need is I'm going to re-up on my science equipment again. Okay, I got to be really safe because we're going to take it up a notch. You always have to take it up a notch, right? All right, so we started off with bubbles, no cryogenic, right? We made that really cool bubble snake. Then we got to our dry ice bubbles. We used 1 cryogenic, so we used dry ice. So that's something that's cold. It's like negative 78 degrees Celsius, but it's not like that cold, right? Now what we're going to do is use another cryogenic, okay? So give me 1 second here. Now, to use this other cryogenic, we're going to use a very special container. So this is really thick and very insulated. I want you to see how thick the top is itself. Now you'll notice that here at the bottom, there's this really cool square, and that's intentional because at the bottom of this container, oh, hold on, give it a second to focus. Bottom of this container, there's a square here as well. And so what we do is we place the squares on top of each other because I'm about to add something that is so cold to this container that if I added it to the container alone, it would actually freeze the container to my table, and I don't want to do that. Now I also have a tarp in here that for no reason, I'm just going to come over here to my laptop. I'm just going to cover it really quickly because my husband gets mad when I ruin laptops, right? Okay, so now I think we're ready. Goggles, gloves. Oh, I need another pair of gloves. Hold on. Really got to suit up for this one. So here I have my cryogenic gloves. So these are really, really thick gloves. Let me show you again. Okay, very thick, very insulated here. And so what we do is we wear these whenever we're going to play with like a big cryogenic, okay? So if I had my bare hands, I would have put these gloves on to touch the dry ice. But now what we're going to do here is I'm going to add a little bit of liquid nitrogen so you can see here why you never, ever, ever use bare hands. There we go. Okay, quick shout out to my local Austin vendor here. I didn't think I was going to be able to get my hands on liquid nitrogen for y'all, but they got me a little bit. Let's see, is it enough? Oh, it's enough. Oh, it's enough. We're going to be able to make this work, y'all. Oh, thank you, thank you, thank you. Okay, so liquid nitrogen is extraordinarily cold. It's 77 Kelvin or negative 194 Celsius. You would never take your hand and put it directly into the bucket. Never, never, never. However, if you have your cryogenic gloves on, and if you have 2 containers like this, what you can do is fill the container with hot water. 1 second here. And you can add the hot water to the liquid nitrogen, okay? Here we go. Got my clicker, got to cover my clicker. Here we go, guys. Thank you all so much for coming. I am so excited. I'm going to answer a few questions after this when we have just a few more minutes, but thank you all so much for coming. If you're interested in seeing any of my books, please check out the local bookstores here. But yeah, my next set of books comes out on May 11th. Here we go. 3, 2, 1. about this experiment. I was so worried I wasn't going to have enough liquid nitrogen, but I absolutely did. So this is vaporization. The liquid nitrogen takes the thermal energy from the hot water and it goes from the liquid state to the gaseous state, and that's what's happening right here. Like I said before, y'all, I'm Kate the Chemist. If you want to know more, check me out on my website, katethechemist.com. You can follow me on social media at the Kate the Chemist for either Instagram or TikTok. I'm new to TikTok, so go check out my videos. Let me know if you like anything that I'm doing. And now I'm going to answer a couple questions. All right. Hi, everyone. Did any questions come in? Let's see here. All right. I don't see any questions, so I want to just add one more thing. My next book comes out on May 11th, which is the Birthday Blast Off. That's the 4th book in the fiction series. And then the next nonfiction book is called The Awesome Book of Edible Experiments, and it's 25 experiments that you can eat. So every single one you can do, you can actually eat in your kitchen. So you can finish it, you can eat it. It's amazing. I am so excited about that book. I can't even tell you. I wrote that one in May when the pandemic was really bad and everybody was quarantining here in Texas, if y'all remember, like you wanted to stay inside. So I basically locked myself in my house for 3 weeks. I opened my pantry and I tried to figure out what was in there and what I could use to make 25 experiments. It was so much fun. My husband loved it because he was constantly trying new foods, different things. I show you guys how to make ice cream, 2 different ways how to make ice cream. I show you the difference between using baking powder or baking soda in your cookies. I show you all these different aspects, which I think is just so fun, and I really think y'all will enjoy it. If there's no questions, I just want to say thank you all so much for coming. I really appreciate your time. I've had such a blast, and I hope you all have enjoyed a couple experiments with me on this lovely Saturday morning in Texas.
That was so exciting. I believe that's the first ever San Antonio Book Festival explosion. So, congratulations.
I asked my publisher, I was like, what do you think? Can I do it? Can I do that? And they're like, yes, always go for an explosion. We can do at least one.
Well, thank you so much, Dr. Kate. Your program was wonderful, and thank you for sharing it with us.
Of course. Thank you so much for having me. I've had such a blast writing these books. I can't even begin to tell you how much fun it was. And I have already got some other ones up my sleeve for what's next, but I'm not allowed to say anything yet. For any adults in the audience, I've also written my first adult book it's a nonfiction book for adults. I gotta be careful. I keep saying adult book, but it's a nonfiction book for adults. And it's called It's Elemental, and it's a hidden chemistry and everything. And it comes out on July 13th. And I basically walk you through an entire day and talk about the science of everything from breakfast to a workout to getting ready to going to the beach, going to happy hour, and even the science of the bedroom. So it's a really, really fun book that I'm looking forward to sharing with you all.
You are so busy.
You know what? I am busy. I am. I heavily depend on at least one Diet Coke a day. But after that, you just got to try to follow your dreams, right? Whatever you love, it doesn't feel like a lot of work when you enjoy it and you love what you do.
That's so great. Well, thank you again, and thanks to our audience for joining us. And I will go ahead and sign off now. Thanks, everyone.